Hello students, welcome to EPhysics. Students, in this video we will be discussing about the electric field on an axial line of an electric dipole. What do we mean by axial line, students? Like, let us consider we have two charges, 2 point charges, that we will create a dipole, that is two equal and opposite charges. Let us consider this is minus q and this is plus q. Okay, and let us consider this is the line joining the two charges, that is the dipole, matlab two poles. This is the midpoint. Let us name it as O. Then the distance between this O and minus charges will be A. Therefore, since it is a midpoint, therefore the distance between minus plus of charge and O will be again A. Therefore the length of the dipole will be twice of A. Axial line means at any point on the same line joining the two charges, that is the minus and the plus charge, at any point on the same line, if we produce the line, that line will be considered as axial line, and any point on that axial line we will consider any point where we will consider the electric field, where we will be finding the electric field. Hence the topic becomes electric field on an axial line of an electric dipole. So let us consider, if we produce this line, let us consider at any point, let us name it as P. We have to find the electric field. Let us consider this is E vector. Okay, now due to charge, minus charge, okay, that is, let us name it as A and let us name it as point B. Due to point A, the electric field, that is the direction of electric field, will be on this direction, which will be represented as EA vector, and due to point B, the electric field, direction of electric field, be on this direction, that is EB vector. Clear now? Now therefore, and let us consider this point P from the midpoint of the dipole is at a distance r, at a distance r. So we can say that the distance between B and P, point P, will be r minus a, and the distance between point A and point P will be r plus a. I hope the terms are clear. Now let's proceed. So the net electric field, that is at point E, will be equal to EA vector plus EB vector. That is the electric field due to point A, that is minus Q charge, and electric field due to point B, that is plus of Q charge. Now if we find the charge, electric field due to point A and point B separately, then we will find that if we only consider the magnitude, not taking the direction, we will write the direction later on. If we only consider the magnitude of electric field due to point A, that is minus charge, will be equal to 1 by 4 pi epsilon naught Q upon the distance between point A and B is r plus A, so therefore it becomes r plus A ka whole square, and the direction will be along PA. PA means from point A, P to point A, in this direction, that we have mentioned it over here. Okay, so the direction will be along PA. Again, if we find the electric field due to point B, intensity due to point B will be equal to again 1 by 4 pi epsilon naught, since we have the same charge with the same magnitude. From point, for B, the distance between point B and point P is r minus A, therefore it will be r minus A ka whole square, and the direction is opposite to PA. Therefore let us consider this is on this direction. Let us consider this is point X. Okay, and let us take any point on the right side, Vx. Therefore this will be along Px. I hope the thing is clear. Now we can see it over here that point B is closer than as compared to point A from point P. Therefore, the intensity due to point B, that is the positive charge, will be greater than intensity due to point A, that is the negative charge from the figure. So since EB is greater than EA, okay, EA, therefore we can write it as that E vector will be equal to, if we take only the magnitude also it is fine, it will be equal to magnitude of E vector, EB vector minus EA vector. Since EB is greater, therefore the direction will be along EB, and the direction of EB is along PX, therefore it will be directed along PX. Clear? Now, so if we finally conclude the things, we find it over here that E is equal to 1 by EB is equals to 1 by 4 pi epsilon naught Q upon R minus A ka whole square minus again 1 by 4 pi epsilon naught Q upon R plus A ka whole square. Is it clear? Now, if we solve it further, what do we get? This is 1 by 4 pi epsilon naught common in both. Now here we can, if we take the LCM of it, this is R minus A into R plus A. We know the formula that A plus B into A minus B is equal to A square minus B square. So here we will be we will get that A R square minus A square, and we have the whole square in both the terms, therefore the whole square of both the terms. Here R minus A gets cancelled, therefore we are left with R plus A. Here Q is also common in both, so let's write Q also. Here we will be finding R plus A ka whole square, R plus A ka whole square, and again the negative sign over here, so negative sign, R plus A gets cancelled, and we are left with R minus A ka whole square. So this is the next step. So if we move further, we will again find 1 by 4 pi epsilon naught Q. If we solve R plus A whole square minus R minus A whole square from A plus B ka whole square, that is A square plus B square plus 2ab, and R minus A ka whole square, that is A square plus B square minus 2ab, then we will come to the conclusion that we get 4 into AB. Okay, so and in the denominator we already have R square minus A square ka whole square. Okay, let us consider this is equation 1. Also we know that the dipole moment P is equals to twice of A into Q, that is the length of the dipole multiplied by Q. So if we write it like this, if we write equation 1 as this, that sorry, my mistake, E vector E, that is the electric field intensity, equals to 1 by 4 pi epsilon naught, and here if we write it like this, 2 into 2 A Q 2R into 2A Q divided by R square minus A square ka whole square. So we will be left with 1 by 4 pi epsilon naught 2 into R into 2AQ is nothing other than P, therefore it will be the dipole moment P divided by R square minus A square ka whole square. So this is the formula for electric field intensity. Okay, electric field on an axial line of an electric dipole. Okay, so this is the formula. Now students, that what will be the direction of it? The direction of electric field on the axial line, the direction of electric field on the axial line of the electric dipole is from minus charge to plus charge. We have already discussed it in the previous video. Okay, now if we consider any case like the first case, if we consider the dipole is of a very small length. Okay, if the length of the dipole is very small, length of the dipole is very small, in that case what will happen, that the length of the dipole, that is a, will be very less than r. In that case a square can also be neglected. A square will be neglected. Since a square is neglected, so from this equation we will find that a will be equal to 1 by 4 pi epsilon naught 2 rp upon r to the power 4. Okay, so we will be finding that E will be equal to 1 by 4 pi epsilon naught 2 rp upon r square ka square, that is r to the power 4. This r and 1 r gets cancelled, we are left with E will be equal to 1 by 4 pi epsilon naught 2p upon r cube. So this is the formula. Finally we get it. I hope you understood the things very nicely. The PDF of this will be uploaded in the Telegram channel, that you will find the link of the channel you will find in the description box. Thank you very much for watching.